is the serial one. We have ethane that can be chlorinated once, producing some hydrochloric acid, and what is that? 1 ethane chloride, whatever. That one can then react with another chloride molecule to have a double substituted and some more acid. Again, we're being given some extra information, but for now, let's just start and set up this system. So we jump to the other one I have here. Again, I have a feed stream. I have a product stream. And I have a percentage of C2H6. I have a percentage of Cl2. I have a percentage of the one I'm interested in, C2H5Cl. I have a percentage of HCl, and I have a percentage of C2H4 Cl2. So the product I'm not interested in. And what else are we told? The system is to be designed to consume all of the supplied chlorine. So that first information already I can say, well, that means my percentage is going to be 0 of my chlorine. It should be possible to reach a 15% conversion of ethane, blah, blah, selectivity. How much feed and water and what composition must be supplied to produce 100 moles of our product. Okay, so that means in total I have no idea. Actually, all of these, let's see if we can do it. All of these, we don't know what they're gonna be. We don't know how much chlorine to start out with. These two for both of my streams, I am gonna set them to 1 minus the sum of the others, so I don't have to deal with those as being unknowns. There we go. And I can then calculate all of my different components over here. Let's just change them from percentages. I want to replace all of them. There we go. Just like normal, multiply the total amount with the percentage, fill it to the right and down. And that is it for now. So we once again grab all of our molecules, all of our components, paste them transposed. We have carbon, hydrogen, and in this case, chloride. 2 there, 6 there, no there, no there, no there, 2 there, 2 there, 5 there, 1 there, none, 1, 1, and 2, 4, 2. There we go. And again, I can, for my feed and product streams, I can do a carbon, hydrogen, and chloride balance by using the sum product of my first array and my transpose of my second array over there. Finish that off, fill right and down. So if there's 0, everything is fine. We can set up our balance now, in minus out. That gives me 3 equations. I have a ton of unknowns. Technically, these two, I do know they will be 0 because I won't be sending in any of my product into my system. So I can remove those two as well. And 1, 2, 3, 4, 5, 6, 7 unknowns and only 3 equations. So we have to go hunting for a bit more. We are told it should be possible to convert 15% of our ethane. So let's start with that one. 15% conversion. That means that 1 minus 15 won't be converted, multiplied by the amount of ethane I have here, minus the amount I end up with. That gives me one more equation. What else are we being told? We're being told we have a selectivity of 14 moles of the product we want per mole of product we don't want. Okay, so that means, what shall we call that? Let's call it selectivity or select. That basically means that if I take my desired product over 14 and I subtract my undesired product, that should give me 0 if that condition is fulfilled. And finally, how much must we supply in order to get 100 moles of product? Now, I could just type in 100 up here and then do some back calculations. Instead, I'm just gonna put it in as an equation down here saying I want 100 moles. 100 moles of what? 100 moles of that one. So if that one is 0, that means I'm producing 100 moles. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. What have I missed? Let us see. I know that is consumed. That one depends on the others. Have I missed an information? It is because this one is no longer. So, okay, this is going to be a bit difficult to explain, but this variable, so the percentage and the total amount here, cannot be independent of each other because they have to end up yielding me 100 moles of the desired product. So actually this one is no longer an unknown. We are gonna call this, we're gonna define this by taking the mass that we have here, not the mass, the number of moles we have here divided by the total number of moles. Yeah, Excel gets angry with us, that's fine. No, that can't be right, hang on. Carbon, hydrogen, chloride enters. How much feed? That is weird. Six equations. 1, 2. Oh, hang on. That's me who's messing up. This is one of our products as well. So we also know that this one is 0. Then it makes sense. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There we go. This was another of our products we know is 0. So now we basically set it up in Solver. With all of these equations already being 0, I think I'm going to put in some dummy values just so I have something. Oh, what's going on here? That is incorrect. Just have to make sure it's only the percentages. Let's see if I did it up here. No, that looks fine. Let's just put in 50%. And I fire up my solver saying the first equation or one of the equations down there has to be 0. Those 3 have to be 0. Those 2 have to be 0. And finally, select all of my variables. I have those, that one and that one. Let's see. Excel says it found a solution. Did it find a solution? All of it trends towards 0. I'm getting no chlorine out. I'm getting 100 moles of what I desire. So now we have an answer to all of